Okay, let's look at our last piece of notes for this chapter. And what we're talking about today is gravity that you should have already written down. And what is gravity? I think we're really familiar with the idea that the Earth exerts gravity. Right? It pulls on us, it exerts a force on us and pulls us down towards the center of the Earth. But the one thing a lot of people don't understand is that all objects that are made up of matter actually exert gravitational pull on all other objects that are made up of matter. Right. So if you're sitting in your room right now and your computer's in front of you, your computer is actually exerting a force on you, pulling you towards it, and you are exerting a force on your computer, trying to pull you towards, pull the computer towards you. Right. Now, why isn't it that we're like constantly not doing this and going, whoa, I got to pull myself away. Whoa, the computer's pulling. Oh man, the computer keeps pulling me into it. No, the one thing is because a computer has such a small mass that exerts such a small amount of gravitational pull. And even all of us, we have such a small mass that we exert such a small gravitational pull on other objects. So the Earth is one of the only things around us right now that has such great mass that we can notice the gravitational pull. And keeps us down on top of the Earth. So the first piece of the note says all objects are attracted to all other objects. That's what gravity is, right? And then I have underneath the Earth is large, so we have a really large gravitational pull. But a pen, like this guy right here, he exerts a gravitational pull on me, but he's so small, the pull is really, really, really small. So I don't all of a sudden feel like, I'm getting pulled towards it. No, there's that gravitational pull is really, 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 really small. All right. So the second thing, what does this depend upon? Well, it depends upon two things. Number one, it depends on the mass of the object. The mass of the Earth is really, 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 really large. Right. So that's why it exerts such a great gravitational pull, is because it has so much mass. Right. That's why it pulls down on all of us and everything else. And that is also why if you take something and let go of it, it'll fall. Right. And it's all gravity pulling down on that object, trying to pull it down towards the Earth. Right? The other thing is the distance between the objects. The farther the two objects are away, the lower the gravitational pull. So if I go out into outer space, a long ways away from the Earth, right, and I'm talking like beyond orbit, I'm like way out in space, is the gravity of the Earth going to be able to pull on me? No, because I'm too far away from it, so it's not going to pull me back. Right? So the farther two objects are away, the lower the gravitational pull. All right. So those are the two things that gravity is dependent upon. Now, how do we measure gravity? Well, we do a thing called weight. And weight is a measurement of how much that gravity is pulling on us. Now, we're so familiar with this, and we're like, well, yeah, okay, I stand on a scale, and that's how I found out how much I weigh. And what that is that's how much gravity is pulling down on the mass, the matter that I'm made up of, it gives me my weight. So now if I can reduce my mass, that means make me have less matter, lose weight, then all of a sudden I will weigh less because I reduced my mass. Right? I reduced how much matter I'm made out of. So mass is the amount of matter that I'm made up of. And then gravity pulls on that, and we measure that in the way of weight. So understand that weight and mass are not the same thing. Right? But unfortunately, we commonly kind of think that they're the same. So remember that mass is the amount of matter that's in an object. Weight is how we measure that by how much gravity pulls down on it. We actually measure mass in a thing called newtons, which is its symbol is a capital N. And if I have 1 kilogram, which would be like, about the size of a grapefruit would be about 1 kilogram. That, if I put it in newtons, is 9.8 newtons, right? And later on, coming up down the road here, we're going to have another thing that comes up and it's going to point out as to why is it 9.8. There's a reason for that number, but that'll come up later. Right? So 1 kilogram, that grapefruit's going to be being pulled towards the center of the Earth with 9.8 newtons. Right. So a human, an average sized human, probably is going to weigh, because actually this is the scientific unit for weight, about 450 newtons. Right. So I lay odds that the way in which we as Americans are, how we don't like to tell everybody how much we weigh. I doubt if we want to use newtons, because that average human, that's somebody that weighs about 120 pounds, 130 pounds, and to tell everybody that you weigh 450 newtons, they'll be like, wow, you sure don't look like you weigh 450. And you can go, well, that's 450 newtons, not 450 pounds. Right? So you got to understand that that's a scientific measurement with newtons. Right? And it is really that you take the kilograms, you multiply by 9.8. So, all right. So now the moon actually exerts gravitational pull, but its gravitational pull is 1/6 of that of the Earth. Now, why is it so much less? Well, because the moon is so much smaller, but it still has a large enough mass that it does exert a gravitational pull. And that's why if you ever watch a video, and you can go online and look at videos of people on the moon, that they sit there and they like bounce really, really high. Why can they bounce really, really high? Well, for myself, if I weigh 240 pounds, and we'll use pounds because it's something we're familiar with, that's sitting here on the Earth. That's because of Earth's gravitational pull. If I went up to the moon, I would weigh 1/6 of that. So out of 240 pounds, I would weigh 40 pounds. So I would feel like 40 pounds. Well, man, if I only weighed 40 pounds, excuse me, I'm going to sneeze. Excuse me. Do it again. Excuse me, goodness. But if I only weighed 40 pounds and look exactly like I do, right? I understand I'm not going to all of a sudden shrink, right? I'm not going to all of a sudden get smaller. I'm still going to be the same size I am. It's just because gravity isn't pulling on me as much. I could probably like push myself up and go flying up and like slam a basketball really, really easily, because it wouldn't take very much to lift up or throw up 40 pounds up in the air, which would be my entire mass, right? So if a person weighs 480 newtons on the Earth, what do they weigh on the moon? Well, you got to take and divide that by 6. So that person would have newtons of 80 newtons. And I used pounds a moment ago to show you something that you can relate to. So something else that goes along with this is how does gravity relate to the concept of oh, wait a minute. No, sorry. We're going to come back to that later. Sorry, I'm jumping ahead of myself. So, all right. So the last thing on here, how does a scale work? Well, a scale pulls down on a spring. So there's a spring inside that scale that you stand on in the bathroom if you're checking to see how much you weigh. There's a spring in there. When you step on it, that platform actually goes and it pulls down on a spring. And that spring actually exerts a force going up. Right? So we have our gravitational force pulling down, and we have the spring pulling up. Well, when it ends up making a balanced force, then that spring actually pulls on a dial, and the dial actually goes like this and goes up to a certain point. And that point, which has been predetermined, tells us how much we weigh, how much that gravity is pulling on whatever mass there is on top of it. So it pulls down on the spring until the upward force equals the weight of the downward, which the weight is the downward force of that object. Once it makes a balanced force, then we end up knowing that that is the weight of ourselves or whatever object we just placed on the scale. Right? So again, it just turns out to be a balanced force between a spring inside of the balance and gravity pulling down on the object, which might be you standing on the scale. So that's how a scale works in order to help us measure the mass, which relates to gravity pulling down on that mass, right? And we can actually measure the weight of an object. All right, well, that concludes this chapter. All right, and now it's time to move on, and ultimately we're going to do some review questions, go over those review questions, and it's going to be time to take another test. So we'll see you. Have a great day.